I'd like to talk now about the concept of covariance. We've talked about the spread of data using the standard deviation. The standard deviation squared is called the variance, and that refers to a single population. When we talk about covariance, we're talking about two variables as they relate to each other, how their spread of observations are related. They could be not related at all, in which case the covariance would be 0. Or they could be related a lot in either a positive value or a negative direction. So we're going to look at the covariance between vitreous chamber depth and axial length. And if we remind ourselves, the standard deviation is the sum of the residuals squared. You could also write this equation as the sum of x minus mean of x times the sum of x, or sum of y minus mean of y. And in fact, when you talk about covariance, that's what we're looking at. We're looking at the sum of the mean of x, or the sum of x minus the mean of x times y minus mean of y. And then we take the average of that by dividing by n. Up here we said n minus 1, but here we're just looking at the mean. So let's look at these values. Here we have the standard deviation of vitreous chamber depth. If we look in here, we can see our formula is standard deviation of the column under vitreous chamber depth. Similarly, if we come down here, you have the standard deviation of axial length. And then what we do is we actually compute. We have to, we may be able to have a function that gets at this, but let's look at how this works. So we have vitreous chamber depth, which is the value x, this minus this fixed value. So for each of these cells, we're going to take the vitreous chamber depth observation and subtract it from the mean vitreous chamber depth. That's our x minus mean of x. And we're going to do the same thing with mean axial length. And then, because as in this formula down here, we multiply those two residuals or differences, we do that right here. Oops. So we're multiplying the difference between vitreous chamber depth and the difference from the mean for axial length. And then we take the average of that column, and that's the covariance. In this case, the covariance is 0.78. The covariance ranges from, if you multiply this standard deviation times that standard deviation, you get a number, and the covariance ranges plus or minus that number. Now, an interesting thing about covariance and the relationship to that with correlation is that covariance, or the correlation R, the Pearson R, is the covariance divided by the standard deviations multiplied by each other. So if the correlation was 0, this correlation covariance would be 0. If the correlation was 1, then this covariance would equal this standard deviation times this standard deviation. and that's covariance. A lot of statistical procedures and the like that use the term covariance, so I wanted to let you know what that means.